Generative design is a highly functional advancement in product development. Airbus, for example, wanted to redesign their partitioning wall, a wall that separates the passenger compartment with the galley or the kitchen. That wall used to weigh 65 kilograms before, and they searched for ways to make it lighter while still meeting the same strength requirements. And they ended up with a computer-generated design, one that is 45% lighter while still meeting those strength requirements. And this way they save up to 3,000 kilograms of fuel per plane per year. So what is generative design? The aim of generative design is to create structures that are optimized for given metrics. These metrics can be strength, cost, material usage, or even thermodynamical properties. Given these metrics, a computer program generates multiple 3D designs that optimize for the given objectives. The creator can then pick and choose the one design that fits his needs best. Generative design is not a tool that creates a one-off perfect product. It is a tool that inspires the creator and generates all kinds of possibilities that the human brain cannot even come up with. The problem with this approach is that it's highly complex and it needs a lot of computer power. That is why researchers started looking for patterns in nature. Patterns that have been evolving for 3.8 billion years by natural evolution. Using the knowledge gained from these patterns, they deducted some rules in order to decrease the complexity of these programs and thus decrease the computational power needed. In the Airbus, for example, they used slime mold and how that mold finds optimal paths between food sources in order to make the optimal layout for the tubes in the wall. For the inside of the tubes, they looked at mammal bones and how they are structured from the inside in order to make a very strong yet lightweight and durable material. This approach of biomimicry inspired artificial intelligence researchers to stop looking to nature for patterns to use in their products, but to try and create their own evolved products, specifically designed and optimized for the metrics that they need. And the researchers used so-called evolutionary algorithms. These algorithms create many structures with slight variations and measure the performance of each individual structure. Only the best structures get to create the offspring for the next generation. The next generation also has some very slight variations, gets measured again for performance, and then gets decided who can create the offspring again. Just like nature, this way only the best structures keep surviving and creating the next generation, and we can optimize the structures for the metrics that we need. This approach mimics the evolution of nature, but this time we can use it for one product specifically, and we don't have to wait for billions of years to get the result. So we talked a lot about what generative design is and how it works, but let's see what you can actually do with it. Sports companies such as Under Armour and Nike need to create the best running shoes out there. And good running shoes needs very good soles. And the soles of a shoe need to be flexible, they need to be light, they need to be springy, durable and very strong. And all these requirements make it very, very difficult for a human being to design such a structure. So they use computer-generated designs in order to create the best sole and thus the best running shoe out there. Application 2. Many day-to-day products have generative design embedded within them. For example, small industrial parts used within the production of larger products need to have very strong qualities and little material, while also being very easily producible. A combination of generative design and manual design is often used to get those strong qualities and little material combined with the ease of produce. Application 3. Next to Designing products, generative design also lends itself very well to designing layouts of spaces. Autodesk, the company behind one of the largest 3D modeling tools that also has generative design functionality, started to question their employees about their preferences and needs for a working environment. Questions like, how much light do you want on your desk? How many meeting rooms versus working places do you need? How many times per day can you be distracted? Or what is the level of noise that you could handle? They were all used as parameters for a computer model that generated the design for their office. From all of the designs generated by the model, they picked the one that fit their needs best, and they built the office in Toronto, Canada. With the rising need of more strong and durable materials, combined with the decrease of natural resources, it is inevitable that we need to think more carefully about how we design our products. There's no escaping generative design in the future. Thanks for watching the tech update on generative design by BIT, and I hope to see you in the next one.